Okay, so we're getting more into the number type approach to this topic, and the first thing is called sampling proportions. Now the word proportions, don't get worried about that. It's just like a fraction or a percentage, okay? A fraction, decimal, or a percentage. Okay, so proportions are parts of a whole. Okay, so don't get too fussy about that. So if you were, for instance, if you were checking whether vitamin C decreased colds, you might get one sample to take no vitamin C, one sample group to take 1 tablet, and one sample group to take 2 tablets. And then you could look at the frequency, how many people in each group got a cold. Okay, so you don't need to copy anything down there. I'm just talking about an experiment. Okay, so the number, first of all, the number of people who catch a cold is not important, okay? Because it could be the group size is 1 million and only one person caught a cold. But if there were 2 people and one person caught a cold, then that's more significant. So the number of people is not important. It's the proportion of people, and the proportion could be written as a fraction, or could be written as a decimal, or could be written as a percentage. So the proportion of people who catch the cold is the most important thing, okay? So let's have a look at an example with these numbers. Okay, so here's a definition. So P per proportion, they put a hat above it to indicate it's a proportion. Don't worry about that. And X is the number of successes, like how many people catch a cold, and N is how big the group size is. Okay, so that is important, so copy that down. Okay, that's called the sample proportion. So if we had 20 people in a particular group, took no vitamin C, from 20 people in a group who took no vitamin C, 8 people caught a cold, what is the sample proportion of colds? Well, 8 people caught a cold, and there were 20 in the group. So that could be written as a decimal as 0.4. So the sample proportion is 0.4 or 40% or 2/5. It doesn't really matter. So copy that and come across. Now, you could expect, the sample proportion to match the successes if you looked at the whole population. And obviously the bigger the group, the better the group. So we talk about variability in the sample proportion. So it decreases as the sample gets bigger. Okay, so as the bigger the group, whatever answers you get would be more likely to be the answer that you'd expect for the population. And the question I'm asking now is, when would it be exactly the same? So think about that for 5 seconds and then pause, and when you come back, okay, you're back. So the only time is when the sample was the population. That's the only time you can get it exactly the same. Otherwise, it's just going to be some margin of error. Okay, so copy that and come across. Okay, so as I said, this proportion is an estimator of the probability of the occurrence in the population of whatever we're measuring, whether it be catching a cold or whatever. So whatever we're trying to measure, then P is an estimator of that occurring. Okay, so here's another example. At a checkpoint, 55 cars were checked by the police for roadworthiness. 7 had minor defects, 7 had major defects. Question number 1, estimate the probability that a randomly selected car has a fault. And part B is more interesting. What's the trouble with this answer being a reliable estimate? So part B, you probably won't have much of a clue at this stage, but part A you should be able to do. Okay, so in part A, we've got the police, so P hat, we had 7 plus 2, we had 9 cars with faults out of 55, and that is approximately equal to, I think, about 0.16. So that's the easy part. But what's the problem with the way you did it is that the police were choosing cars to check, and they're not gonna not check new cars or cars that look new. They'll only pick the dodgy ones, or they'll pick cars with young drivers and things like that. So it's a bit dodgy in that the cars were selected at a checkpoint, and you've gone past police where they wave some people through and they pull other people in. So that's the reason that it's not really reliable, is because the cars, okay, that's saying that 16% of cars have a default, but 16% of the cars that were picked by the police as being possible defects. Okay, so come across when you're ready. Okay, there's the exercise. 904, questions 1 to 8. Thanks, bye.